So this is going to be our presentation about our LLM CTF project that you guys so generously funded. We're going to be going over the comprehension structure that we use, starting off with the problem that we want to solve, and going into how we evaluated all of our agents. We're going to describe the basic architecture that we were provided by the club, and then each of us modify it in order to build our own agent. We're going to describe how we chose an LLM in order to power this agent, and any notable advancements from each of the teams that were made. Then we're going to go over the results, both from each individual round, where we would test it against challenges that other teams submitted, and our final evaluation against CTF. And lastly, we'll go over what's next for this project.
Just to get started, I'm going to discuss a bit about how we decided to organize this competition as GreyHat. So we structured it we got funding to have 8 teams with 4 students. We had 51 people apply for this project, of which we accepted 37 members. Planning to have weekly submissions where every round teams would be able to submit a version of their agent, as well as a CTF challenge for that round. We then give teams offensive and defensive points, depending on how they perform on those valuations. Similar to CTF, we would give teams points for if they were able to, basically how many challenges they were able to solve, and additionally defensive points for how well their challenge fared in the face of other agents. Unlike CTF, which tries to optimize for N by 2, we try to optimize the agents for having at least one submission, even if that, or having one agent able to solve it, even if that agent is your own agent. We also did specifically go in and make sure that submitted agents did not hard code or have very niche logic to try solving specific agents or solving specific challenges. Just some statistics about people who applied. The greatest proportion of students that applied for the project were first years, though we did have a good mix across graduates and other undergraduate years as well. People across the board were interested in multiple different parts of the project, from the LLM agent development to CTF methodology to software engineering. A good chunk of people actually didn't have CTF experience coming into this project, but provided that they had sufficient other project or software engineering experience, we okay them to work with us. And with regards to how people heard about the project, most people have heard about it through our regular weekly meetings.
So this is our motivation objective for the project. Better LLMs, they like closed loop interactions. They provide static feedback, and they're not autonomous. And they also struggle with context that over hard challenges, they failed to plan over multi-agent codings. Our goal is to develop an autonomous LLM capable of solving various CTF challenges end-to-end. This is our boilerplate architecture that everyone started off with. Every agent, it gets spun up in a Docker container. And for the challenge detection, it will be file-based or network-based because some teams, they have different methods for solving different types of challenges. And then everything will get evaluated here. We would log whether it's seed or not, the cost. But yeah. For evaluation, there's a categorization. For rapid go, it will solve it locally, and for point web, it will next to a server. Or in the container, it lives in the container. It also can have MCP tools and libraries that team founded. And for the flag resolver, this would check if our flag is validated against the correct flag. For testing, we tested our own challenges, and then later we tested against the CTF, which is the live challenge.
Now it comes to actually choosing our LLM. So from the boilerplate architecture, we started off with a combination of GPT-5 Nano as well as Gemini 2.5 Pro. These two agents were mostly kept by all of the teams for at least the first round, and then after that, many teams decided to look to other LLMs for cost performance metrics as well as preferences. Some notable models chosen were Claude 4.5 as well as Sonnet 4.5, and at GPT-5, and again Gemini 2.5 Pro. And some teams, like Team 1, we used open source models through OpenRouter such as GLM 4.5 Air, GPT-OSS 120B, as well as DeepSeek R1, all for the purposes of testing the functionality of the agent as well as its interoperability with MCPs, more so than actually trying to solve the challenge itself. After that, we kind of broke up into two separate paths. The first path being that most teams stuck with the boilerplate architecture, but build it on top of it and turning it into a more agentic tool by adding MCP tools as well as like some tier agent functionality. But other teams, such as Team 5 and Team 7, decided to use already on the market pre-built solutions for this sort of agentic interaction, like Claude Code and Codex. Speaking of MCPs, it allowed the LLM to directly communicate with various CTF tools that are very good for solving CTF challenges, such as Radare and Z3 Solver for like single calling like static results, and also interactive sessions from tools like Pwn Debug, which is based on GDB, as well as Ghidra. Our team 1 also included an exploitation-focused web browser, which like provided some sort of hints to the agent as to like stuff that might be worth exploring. For example, like a array link on a page, as well as like potential for cross-site scripting, perhaps. But other teams, like Team 7, decided to opt out of this, but you'll see why this still became a problem during the results.
Yeah, so there was some problems with the MCP. For example, for Team 1 and Team 7, the MCP had a timeout handling where it will try to process the requested command. And so one solution was what Team 7 did, was they switched to Codex because Codex have their own MCP, and that worked phenomenal for them. For us, for Team 1, we try to add a time limit on the MCP so it doesn't infinitely try to process the requested command. Another problem that we noticed for the MCP was that it failed to communicate properly with the LLM. Sometimes the MCP would produce the wrong format or corrupt results to the LLM, and the LLM will treat that as some result it has to use to solve the CTF challenges. And so it'll essentially give the LLM the wrong idea. This problem was never fixed, but attempts like prompting the agent to not use the corrupt result was used to reduce this problem.
So the team that I was on, Team 7, what we decided to use is Codex. I know that Team 5 that Gary was on used Cloud Code, and he had a similar process. But what we did was we used OpenAI's Codex CLI tool in order to run our agent. And it comes with a bunch of MCP servers and tools available to the agent that's already set up in a harness for it to use, like file operations, shell execution, web search, planning and to-do, and even sub-agents, although we didn't use the sub-agents yet. And all these operations are well tested and developed by the engineering team over at OpenAI. So we didn't have to worry about any edge cases or efficiency. Like for example, for file operations, instead of returning the whole file, you just make sure that it goes to a specific line, changes that, uses all regex and all that stuff. And it also is subsidized by OpenAI because it's a product that they're trying to get more people to use. We only had to pay $20 a month for a subscription, but the quota that we were given is about like $40 of API usage per day, although we only probably use like $40 a week, but still a lot more than we end up paying for the subscription. And the last thing is that there comes with a system prompt that guides Codex in making the agent work properly for like CTF and stuff like that. Because sometimes it can say that this is like a hacking thing, or this is something that's not ethical. But the system prompt guides it and makes it understand that you should always do what the user is asking, and really helps it guide it to solving it properly.
Another feature that Team 1 implemented was a tier agent, where we have two agents. One agent used a tool to analyze the file and then passing the result to the other agent. The other agent will parse the data and then submit it. This reduces complexity within each agent and improve reliability. And since this provide a clear separation of responsibility, if there ever comes a problem with one of the agents, we'll be able to identify which problem it will be. The problem was that the two agents did not assist each other. And so the agent that's responsible for parsing the data and submitting it, it will try to it will cause hallucinations and produce its own hallucinating string, CTF flag, and submit that instead. This problem was never fixed, and so the two agent was reverted to just one agent.
Something that my team 7 did, we didn't want to continuously update the agent manually after each round or after every time we want to improve the agent. So what we did is we created a trainer agent, which is another LLM, and basically it had access to shell operations and file operations, and it would run from the terminal the CTF agent and ask it to solve a challenge. And then after that, it would look at the logs that was outputted and go through the process that the agent took to solve the challenge and figure out where it went wrong. Why wasn't this able to solve a challenge? Or why did it take a few detours and inefficient to solve a challenge? And this trainer agent would have access to the internet, so it can look up new strategies. It would have access to write-ups for a challenge, so it can see the intended solve. And from there, it could make edits to the agent. So we didn't make it like edit the code base or anything that big, but we did give it access to markdown files that were in a structured folder structure that were given to the CTF agent. And this way, the trainer agent could give new strategies, new techniques, and a different idea to the CTF agent, and also different tools that it can use. And so this was run.
Why was it the access to the original source code of the agent?
Because this is something that we could do in the future, but we want to start off with small changes just by updating like the instructions given to the agent, because we were worried it might like be over ambitious in its changes and end up breaking the original CTF agent. And then so we reran the trainer agent, and we had a CTF challenge database, the NYU database, and we kept doing that until it could solve more and more of those problems. And this was only possible because we had the codec subsidized API usage, because it got pretty expensive in order to keep running this loop. So that was very important.
So here's our intermediate results. We have two graphs. One of the graphs represents the results for each team per round, while the other one represents the cost for each team per round. And there were some things we want to point out is that team 4 dropped after round 2. If you noticed that 3 and 4 were combined, and that was because round 3 there was some infrastructure and agent issues throughout each of the teams. So round 3 and round 4 was combined. Another thing we wanted to point out was that Team 7 agent also illegitimately solved 3 challenges in round 3, 4, and 5 by getting the key from the container environment. Another issue is that it tried to use curl to look for write-up online when the web search tool was disabled. And so we removed that from those challenge pools. And we would also like to say that those 3 illegitimate solve challenges were also unsolvable. So that's also why we removed it from the challenge pool. And another thing, if you notice here in round 3 and 2, you notice that there was a slight dip in team 1, team 7, and that was because that the MCP there was an MCP problem for team 1 and 7, and so that's why. Overall, though, every team was able to perform better than the base agent.
I have a question. Which benchmarks do you use for each round?
We just use the benchmark of how many challenges we're able to solve out of so for example in round 1 and round 2 there were 10 total challenges, and we wanted to see how many that was able to solve from that, and then round 3 was 12 challenges.
And which benchmarks like NYU?
Challenges were submitted by other teams in the same style CTF, where each week each team would submit 1 challenge, and they're all the would work on it. Rocket also had, I think, maybe 3 to 5 challenges per week that he would provide, usually from Seesaw.
Thanks.
So after each individual week's progress check, at the end, we all ran against TK-CTF. What we did is we combined all of our agents into one combined agent to put the strongest foot forward that we could. After evaluating the results from each individual round, and looking at the features of each agent, we decided the best course of action would be to start off with my team's agent, Team 7, and incorporate a couple of the MCP servers that Team 1 developed. So putting all that together, we competed in TK-CTF. I ran the challenges, but we didn't have a fully functional connection to the TK-CTF website. So we did is we manually copied the challenge files over and submitted the flags. And we were at 12th place at one point. I think halfway through the challenge, because of course the LLM can solve the challenge faster than humans. But it ended up in the end around 27th place. Part of the reason for that is that we were mainly using the free what? Yeah, 27th, yeah.
Okay.
Part of the reason for that is that we were mainly using the free codex guides, and we didn't want to use too much API usage because it can run for a long time before it gets to conclusion. But after TK-CTF was over, what we decided is that we want to run it fully against the problem suite and see get a comprehensive view of what it would have actually solved if we let it fully run out. So we did that, and we found that it solved 18 out of 32 challenges, which would have been equivalent to 20th place at the very end of the competition. It spent an equivalent of $39.47. We found this because Codex will give us a token count usage after it runs, and then we use the API pricing in order to convert it to an actual cost, even though we didn't actually get billed that. The API pricing used was for output tokens. We assumed all the tokens used were output tokens, but in reality, input tokens are 10 times cheaper, but we thought we'd have an upper bound.
So how many challenges that the winner solved in TK-CTF? Do you remember?
You're talking about the cloud code person?
Yeah.
27.
27. So the person who won TK-CTF challenges last time, he actually improved the cloud markdown file by itself after solving one challenge at a time. And this one could solve almost more than 27, like 27 out of 32. Without doing any agentic architecture stuff, just modifying the markdown file.
Did he manually modify it, or did
manually modify the over the entire mess.
Okay.
Well, I think cloud code also modified.
It helped them modify too.
But ultimately, the what he used was not like a custom cloud code architecture. It was just given some markdown skills.
We do want to mention about our results, though, is that we had for the final results we had no human in the loop when solving these challenges. This was completely automated. The only thing that the human did was say what challenge they wanted to be solved, and and from there, this was the 18 out of 32. And also to mention is that in the live while TK-CTF was running, while the collab agent was run, there was a human in the loop to assist during certain parts.
Do you think if you had more budget, you would have greater results, or if this is a fundamentally an architecture?
Yeah. So we cut off the codex agent at 20 minutes of runtime for all the challenges. That's why you can see that there's like a limit to how much it would have spent. But we think that a few more challenges could have been solved if we gave it significantly more runtime. But we don't think we think some challenges just require some challenges could be solved with more runtime, but not all of them. I think.
So now this competition is definitely over, but the project is not even close to over, and we plan to do a lot more with these agents. Well, for one, we want to reduce some of the hallucination that Kevin was mentioning earlier with like the context poisoning from MCP calls, as well as refine prompts so that it can handle CTF challenges better. Additionally, we want to properly deploy the multiple agent architecture in a working fashion that both agents would be able to mesh together well and understand what each agent wants. Additionally, we want to expand upon like the logging system that Team 7 built, and we want to track like the sort of failed approaches and document them so we can learn and prevent repeated mistakes. We also want to do a lot more research into emerging agentic frameworks as well as CTF solver technologies, and evaluate how these new technologies could be implemented into our system to create the best CTF agent possible.
And huge thanks to SSLab for funding this project and GreyHatGT. decide about this. Any questions? No, thank you.
One thing, so you said you guys will document the errors and, improve your agents. Furthermore, did you try documenting the errors for now, or is that for a future plan? I just want to know if you did. I was just curious what kind of errors were commented on.
Like errors as in the agent not following challenge, or the agent just like falling apart and like airing out.
More like former, not helping.
Oh, yeah, so we have the live logs streamed out. And we have all the logs from all of our past runs still on our computers. The Team 7 was the only one, I believe, that used those logs in order to like in an automated way improve the agent. Although some other teams did read through them manually and saw like, oh, it tried like something that happened was sometimes MCP server wouldn't work, right? So like something that I ran into in the beginning before I used Codex was that the agent would say, now run these 3 commands, and it would give like bullet pointed out shell commands, but it wouldn't be recognized by like the regex that turns it into the MCP server or like invalid tool performance. We noticed that. Or try to call, try to use a tool that says I need this tool in order to solve the challenge, but it's not installed in the system, so we install it. Or something else, some other hallucination or something. But I believe we were the only team that did that in an automated fashion.
Thank you.
So when you're doing reinforcement learning, could you include the human as well? For example, instead of letting the agent to scan through the log file, you can also explicitly guide, and this is how I solve, showing each of the command line and stuff, and let it revise based on how to solve the challenges, along with the failed attempt in the previous round, and see if we can actually replicate yours and see if we can actually improve over time.
Yeah. So instead of us manually going and solving the challenge and telling the agent, what we did is we found a bunch of write-ups online where other people who are better at solving CTF challenges than us had a detailed write-up about every single thing that they tried, and we gave that to the trainer agent.
But like that's a little bit different from the self-improving, because write-up LLM doesn't have any access to the original execution environment and attempt log, for example. If you have a failed attempt as a log, what command line and MCP to call like stuff, all recorded in the previous failed attempt, plus this is the correct answer that you can actually solve within the challenges. So in the next round of iteration, it can probably pick a different tool because of your attempt in the same CTF challenges, right? I think reinforcing in that way significantly improve the process.
Yes,
Nice.
that's something that we can try for this semester.
Of course.
Yeah, like one of the problems we also had was like prompt engineering. Prompt engineering was like very, very important for communicating, telling the CTF agent on what to do. And so we believe that we can further improve on the prompt engineering and also implement what you said, reinforced learning.
So another thing is when one of the practice at Microsoft right now and GitHub for last 3 months, even writing prompt, they don't allow human to write. Let what you want to the agent, and agent will write the prompt for you. I think this type of meta prompting and meta engineering is more significantly important and better than what human can develop. And try to use the multiple model at the same time, not just one model. You don't have to pick the most powerful model, most latest model. Often the result is intermix, that you can just diversify all these together.
And how would you suggest using multiple models at the same time? Like running different agents in parallel, trying to solve it, or communicating with each other in like a tiered architecture?
And whether just isolate each between, so that you can think of it this way. We like to leverage the creativity of these elements. Any other directions, one, probably if you're trained too much, you cannot think about this another easy path. If you're not trained not good enough, like smaller model, like mini series, right? Because it doesn't get trained with the exhaustive manner, it might be completely different one. But if you study too much about a certain subject, you probably not even try. But this GPT or mini, for example, they can try something that the reasoning model and rest model cannot do. But just intermix everyone, isolate in a way that as far as you can validate the final output, I think just running like everything in parallel.
Yeah, that sounds like a great idea. Thank you.
Yeah, thank you.
It's what most of our agents are working as well. When you're designing something, unify, like try to be neutral, agnostic to the model backend, and just provide the model name and such. Like,
Thank you. Thank you.
it sounds good.
But you guys said you ran it on a diverse set of types of challenges. Do you have any insights on what agents perform better on, let's say, is those that perform better on crypto? Any like strategies specific to each domain?
Yeah, so I believe for our team one agent, since I have some experience in reverse engineering and Chrome, I mainly focus on that. And so it did better in like the Rev and Chrome categories. I believe no one's agent is really good at crypto and also MISC as well. There wasn't too much improvement in that. Maybe I'll hand over to Nash. Nash.
Yeah. So you start off with a more diverse challenge set for the first two rounds. Then we consolidate down to just Rev and Cone because we knew that that's what CTF would be focusing on. We wanted to prepare for that. So I think after round 3 and 4, that was the first round where we did Rev Cone only. But before then, we found that MIST was mainly a function of how many different tools you had available because MIST included like sometimes like forensics or like specific image extraction or sound extraction or stuff like that. So it was often based on the tools that the model had available and how you told it that those tools were available and how to use them. Whereas Rev and Cone usually use like some standardized tools. So it depended on the reasonability of the model more so.
I see. So for MISC, I mean, this might be different from your running environment, but let's say you provide some sort of sandboxed environment where the agent can actually download the tool that it wants to use, right?
Yeah, but we didn't give the agent the ability. It probably could technically run a package manager. It just never tried to do that, I believe.
Yeah, it has the the permission to run a package manager, but most of the time it tries to work with the tools that it's provided, as opposed to wasting time trying to install a new package. Like for example, if it can't find like Red for whatever reason, it will try looking for Hydra or try like a disassembly of an object dump and stuff like that.
Part of the reason for that is probably because in our prompts we guide it to tell it explicitly what tools we have available and sort of nudge it in the direction of use these tools. But that could be definitely interesting to give it more free reign to install whatever tools it's comfortable with and try this out.
So Andrew, when you're lecturing CS 65 next semester, I think one thing that you can do is that divide the sections. One people who is interested in solving CTF by hand. Another one, your job is solving the 10 challenges every week, but not solving directly, just your job is to create the agent. So that one group just work on like meta approach of generating agent to solve, but every week we're gonna learn about the same exact tool, but the goal is different.
Yeah.
You have to manually do things. Your focus is just create a one powerful agent and can solve challenges.
Funny
You
you
should
mentioned
do
that.
you should do the experiment.
Okay, yeah, that sounds good.
Volunteer.
I was talking to Fabian about that actually. But yeah, I can split the assignments. I thought that was a bit radical. Yeah, that's good.
Yeah. No one care.
Yeah.
Student will complain for sure, but stuff like this is optional. Some people want to solve through LLM.
Yeah.
We can give a complete option that they can just focus. Like if you see what's happening outside, like writing exploit by hand, this area is already gone. A lot of people already demonstrate that training those exploit is not just for human. There are a lot of indication happening here and there. It's gonna be future. Why not teaching those skills rather than writing?
I think a couple of us are planning on taking that class next semester.
Yeah.
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 And what I think would be really cool is if we did both, where you submit an LLM for the next week, and you also solve the challenge for next week, and each week you submit an LLM and you compare.
By doing so, you have a good idea of what are the problem set in details, what are the things that you have to incorporate to the agent. And then we're gonna increase the like new mitigations every week so that you can think about, solve without those mitigations this way. We have stack analysis, for example, this is the way you can incrementally improve the agent over and over, right? Unfortunately, I'm not here, so agent Andrew and Joshua will be TA too. I think you guys should discuss how to run through this. Okay, sounds good.
Any other questions? All right, thank you so much.
Yeah, thank you.
Much.
Okay.